Alrighty, next up in this process, we're going to talk about this thing called summation notation. Looking at the first three letters, sum means we're adding things up. So the sum of the first n terms of a sequence is represented by this. This symbol here is it's called a capital sigma. Sigma being the Greek letter of the alphabet. So it's capital, and I'll put sigma in quotes because it in itself is a letter. It's kind of like spelling the word W out. It's a letter. It's weird. But it's a capital sigma. So the sum of the first n terms of sequence is you take the first term, you add the second term, you add the third term until you get to the final term. Now taking a look at this notation, this bottom part here, and I kind of wish it wasn't I because I does have meaning in the math. Um, but sometimes we have to just reuse letters. So starting off with I sub 1, it just means you're starting off by plugging in 1. And this is saying we're stopping once we plug in n. So we start with 1, then 2, then 3, then 4, and stop once we get to n. So again, I is that index of summation where you're starting, n is the upper limitation where you're stopping, and 1 is the lower limitation of the summation. In other words, what is the first letter that you're plugging in? Sorry, first number that you're plugging in. So taking a look at this example, we've got 5, and then I equals 5, I can't speak, I equals 1 all the way up to 5 of 3i. So what we're going to do is we're going to figure out the first 5 terms. We're going to do a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and we'll plug those in. So we're going to have 3 times 1, which is 3. The second one's going to be 3 times 2, which is 6. 3 times 3, which is 9. 3 times 4, which is 12. And 3 times 5, which is 15. So those are the first 5 terms of the sequence. We're going to take those and add them up. We got 3 plus 6 plus 9 plus 12 plus 15. Adding all those together, we end up with a whopping total of 45. So for these summations, we're just like finding however many terms we need and adding them together. So next up, we have k equals 3 to 6. Now, k is another letter that's often used instead of I, and this is how we find each term. We have 1 plus k squared. So we're going to take whatever k is squared and add it to 1. So we have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Oh, sorry, I made a mistake here. Here's the mistake. I was not paying attention. This is saying we're starting off at k equals 3 and going up to 6. So we'll start with a sub 3, a sub 4, a sub 5, and a sub 6. So we're going to plug these in. We got 1 plus 3 squared. Well, 3 squared is 9. 1 plus 9 gives us 10. Next up, we have 1 plus 4 squared. 4 squared is 16, plus 1 is 17. Plugging in 5, we got 1 plus 5 squared. 5 squared is 25, plus 1 gives us 26. And then finally, 1 plus 6 squared. 6 squared is 36, plus 1 is 37. So in other words, we're adding 10 plus 17 plus 26 plus 37. Add those all up, we get 90. Bottom one here, we're starting at I equals 0 and going all the way up to 8, and we're going to find each term by plugging them into this. So we're going to do a sub 0, a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, and I'll do a sub 8 over here. So plugging in 0, we got 1 over 0 factorial. That's 1 over 1, which is just 1. Next up, we got 1 over 1 factorial. Well, 1 factorial is also 1, so it's 1 over 1, so we just get 1 again. Next up, we got 1 over 2 factorial, which is just 2, so we have 1 over 2. And then 3, we got 1 over 3 factorial. 3 factorial is 6, so that's 1/6. Plugging in 4, we got 1 over 4 factorial. 4 factorial is 24, so this is 1 over 24. A sub 5, we're going to get 1 over 5 factorial, which is, 1 over 120. That one you can check in a calculator. Just do 1 times 2 times 3 times 4 times 5. Or if you remember where the factorial button is. If you don't, look it up. So next up, we got 6. We got 1 over 6 factorial. 6 factorial is 720. Oh, not 270, sorry. 720. And 7 factorial, we got 1 over 7 factorial. 7 factorial is 5,040. And finally, I kind of ran out of space over here. Let me shift that a little bit. A sub 8, we got 1 over 8 factorial. 8 factorial is 8 factorial is 40,320. So we would add all these up together. 1 plus another 1 plus 1/2 plus 1/6 plus 1 over 24 plus 1 over 120 plus 1 over 720 plus 1 over 5,040 plus 1 over 40,320. And folks, I'm not going to make you come up with a common denominator. It's actually not that bad. The common denominator is 40,320. If you were to add these all up as a decimal, it'd be about 2.72. Not exact, but for the purposes of what we're doing at this moment, good enough.